Algebra 2, Chapter 14, Section 3, right triangle trig. This has its origins back in your geometry class. It's going to kind of remind you of what sine, cosine, and tangent were as you first learned them on right triangles, and then we'll apply this to the reciprocal trig functions and into several examples. On a right triangle, I have one drawn here. I've decided to call this angle here W. I could have called it anything. Could have called it theta, could have called it X. Recall that from that angle, what you have is, of course, on a right triangle, you have a hypotenuse. From that angle, you would have a side that's not the hypotenuse that we would call adjacent meaning next to, right? And yes, the hypotenuse is also next to that angle, but it already has a name. Its name is hypotenuse. So this would be the adjacent leg. And then the side that's opposite it, if you go across the triangle, is also a leg. Okay, so if I just label those triangles with respect to the angle that I'm at, right, the acute angle that I'm doing this trig from, that I've called W, you've got opposite leg, you've got adjacent leg, you've got hypotenuse. Well, sine, cosine, and tangent are ratios based on those lengths. So sine, you once learned, was opposite over hypotenuse. So the sine of W being here, is the side that's opposite it, the one that I have labeled O. Of course, the labels O and A are relative to which acute angle I'm doing this from. I'm here, so this side is opposite. If my angle were here, this would be the opposite. This would be the adjacent. Hypotenuse is still hypotenuse. Sine is opposite over hypotenuse. Cosine, that's the abbreviation COS, is adjacent over hypotenuse. Tan for tangent is opposite over adjacent. This is where SOHCAHTOA came from. So sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent is very conveniently abbreviated SOH, sine opposite hypotenuse, CAHTOA, SOHCAHTOA. Hopefully that's ringing a bell to some things you learned in your geometry class probably last year. Yes, it's true now in Algebra 2 that we do have reciprocal functions, so it would be true that with sine you have cosecant, that's the reciprocal function for sine, of W would be equal to hypotenuse over opposite. Secant of W, remember the S goes with the C goes with the S, that's how we know that these are reciprocals of each other. Secant is the reciprocal of cosine, would be hypotenuse over adjacent, and then tangent goes with cotangent. The cotangent of W would be adjacent over opposite, like that. So then just three quick examples to, again, just turn your brain back on to some things that you learned once upon a time. If I'm looking at this triangle right here and I want to find out what X is, 51 degrees is this angle, X is opposite, 12 is the hypotenuse, opposite hypotenuse, that's the SO part of SOHCAHTOA. You would not be able to solve on this triangle for using the Ka part of SOHCAHTOA or the TOA part. Got to use SO, got to use sine. This is sine of 51 is equal to adjacent over hypotenuse. That would be X over 12. Now I will solve that, but I'll come back to solving in just a moment. Look at the second triangle. Here you have the angle 63. This is the adjacent leg. X is the hypotenuse. Adjacent hypotenuse, that's the Ka part of SOHCAHTOA. We write cosine of 63 is equal to 17 over X. This is the work that should be shown. Whereas in this last triangle, the angle is actually the unknown. Okay, that's fine. And from that angle, 5 is opposite, 7 is adjacent, opposite adjacent. This is the TOA part of SOHCAHTOA. We should use tangent. Tangent of X is equal to opposite over adjacent. That's 5 over 7. If you had me for geometry, I said trig function, angle measure equals fraction. Your work should always say something, your work should always be in that exact form. Trig function, angle measure equals fraction. The trig function is either sine, cosine, or tangent. We always take the trig function of an angle measure. Here it's 51, Here it's 63. Here it's unknown. It's x. Equals. Notice the equal sign is always in the same place. And then fraction as defined by SOHCAHTOA. Okay? And by the way, the OH in SO does represent the order of the fraction. It's not HO, it's OH, top over bottom. AH, top over bottom, like that. Okay? Now let's go back to the first example. And if you're trying to solve for x, what you would do is you would multiply both sides by 12. That's what we get x by itself. You're going to want to make sure that your calculator is in degrees. And once your calculator is in degrees, you want to type in 12 sine 51, and that gets you an answer of 9.3. We'll just go ahead and round to the nearest tenth on all these. X is approximately 9.3. Okay, now watch closely on this second one. When our variable is in the denominator of the fraction, what you're going to want to do is multiply by that denominator to get it out of there. Okay, so multiply by x. Now this is actually not an operation that I would have you show. I'm going to show these two quick operations, then I'm going to back up and show you what you should really do. So just watch. If I multiply both sides by x, now I have x times cosine 63 is equal to 17. Well, cosine of 63 is a decimal value. It's an irrational number. If you want to get x by itself, you're going to need to divide by the cosine of 63. So if you divide by cosine 63 like this, they'll cancel each other out and x would be by itself. You know that whatever you do to the left side, you have to do to the right. So this is what you would actually type into your calculator. X is going to be equal to 17 over cosine of 63. This is what you type into your calculator. Now, with that in mind, let's back up. Do I really need to show that work here? Isn't it really just the case that the x and the cosine 63 can interchange with each other? So this is really the only work that you would need to show, and then you go to your calculator and you type in 17 divided by cosine 63. Again, your calculator must be in degrees or you will not get the correct answer. And here I get x is approximately equal to 37.4. I'm rounding to the nearest tenth. I'm showing you sine, cosine, and tangent on these three examples. I'm also showing you the three different places where the variable can show up. Here the variable is the angle, no problem. We have a function for that. Essentially what you would do, although again this is not work you really need to show, is take the inverse tangent. There's an undo operation on your calculator. It's the secondary function right above that button on your calculator. So sine, it's on my calculator it's blue, it's probably blue on yours, is sine inverse, sine to the -1. On cosine, it's cosine to the -1. Here I'm going to use tangent to the -1. This is the undo operation for tangent. This is what gets x by itself. On my calculator, I do this work right here. Now again, do you really need to show that work? No. You don't need to show the inverse tangent. You know that to get x by itself, you're going to take the inverse tangent, and the work to be done is inverse tangent of 5/7. So on my calculator, the buttons I'm pushing are second tan 5 divided by 7. And that's about 35.5. That's an angle, so that's in degrees. This is about 35.5 degrees. Okay? Now, with that in mind then, let's just blow through a bunch of examples. This would be a handout that if you were here, I would actually give you a handout that looks very similar to this. I have the ability to write on these though, so if you needed to print this and practice it out, I think you could figure out a way to screenshot and do that on your computers. Anyway, the summary of SOHCAHTOA is up here at the top, and also what we said about the reciprocal functions. This next item there says calculators don't have buttons for reciprocal trig functions. We actually ran into that in chapter 13. So to find the cosecant of 20 degrees, for example, you would evaluate 1 over the sine of 20 degrees. If I did the same thing for cosine, well, not the same thing. If I just typed in cosine 57, This comes out to 0.545. If you want to verify that by just doing this along with me, you can. Now, secant of 14, what you would have to type in on your calculator is 1 over the cosine of 14. Again, your calculator should be in degrees for all this stuff. And since it says round to the nearest thousandth, I get 1.030613, etc. That'd be 1.031. I'm just going to go ahead and fill in the answers to the rest of these. And if you're practicing along, just to be sure that you get it right. For cotangent, you'd want to type in 1 over tangent 81. For cosecant, you'd want to type in 1 over sine of 30. Tangent of 45 is 1. Cosecant of 1 degree is 57.299. Next item says to find the measure of the angle theta and then write the reciprocal trig ratio that corresponds to each primary trig ratio. Okay, so to find the angle, what you would do, very similar to what we did on the previous page, is to take the inverse tangent of 4/3. Really, you're doing the undo operation. Remember that addition has an undo operation of subtraction. Multiplication has an undo operation that's division. Squared and square root, they're undo operations. Well, the undo operation for tangent is inverse tangent. To get theta by itself, I would take the inverse tangent to the left. To find out what theta is equal to, then I have to take the inverse tangent of the right. And on my calculator, if I type in inverse tangent of 4/3, I'll get 53.1 degrees. Theta is 53.1 degrees. I've decided to round to the nearest tenth there. Okay? Now, I guess more importantly, for this example, they want you to find the reciprocal trig ratio. The reciprocal trig ratio for tangent is cotangent, and that's simply 3/4. Did you think it was going to be that simple? If tangent is 4/3, then cotangent is 3/4. Okay. If you did this one, you'd get theta is equal to 60 degrees, actually. We could dig deeper into that one, but we won't for sake of time. The reciprocal trig function to this, cosecant of theta, would be equal to 2 over root 3. Now, of course, that's an irrational denominator, so we would need to rationalize the denominator. If you forgot how to do that, you simply multiply by root 3 over root 3, a form of 1, which would produce 2 root 3 over 3. Cosecant of theta, in its correct form, is 2 root 3 over 3. Last one on this page, theta, if you took the inverse cosine of 1/2, also comes out to 60 degrees, coincidentally. Again, we could study that out further. We could go back to the unit circle. Anyway, they want the reciprocal trig ratio, that's what that says there. The secant of theta would be equal to 2 over 1, or just 2. Okay. Just a few more examples. To find theta here, the cosine of theta would be equal to 1 over 3.489. And I don't have a lot of room to stick that in there. Theta would be equal to 73.3 degrees. I'm going to go over here. Theta would be equal to 73.3 degrees. This is how we evaluate reciprocal trig functions. Real quick on this one, theta would come out to 47.0 degrees, just in case somebody wants to check themselves on every problem. Here, tangent of theta would be equal to 1 over 1.597. You type that into your calculator, it's 32.1 degrees. Okay? Now, with that in place, this didn't copy over exactly as I wanted it to. The theta for this is supposed to be right here. It's a little bit out of place. We can find all of the trig ratios. The sine of theta would be opposite over hypotenuse. That would be 24/25. The cosine of theta would be adjacent over hypotenuse, 7/25. the tangent of theta opposite over adjacent is 24/7. Then quickly from that, we can find the cosecant of theta to be the reciprocal of what the sine was, so 25/24, and so on. Okay, and then a couple of just real life examples where you can see SOHCAHTOA in its practical application. Jacqueline is flying a kite at an angle of elevation of 41 degrees. She has let out 18 meters of string. How high is the kite off the ground? In situations like this, I always highly recommend that you draw a picture. Okay, so draw yourself a simple right triangle. Doesn't have to be to scale. Mine almost never are. But here's the situation. The angle of elevation means the angle that it's making with the ground is 41 degrees. The amount of string that she's let out is 18. We're trying to find the height, excuse me, that I'm letting to be h. So now again, we need to refer to SOHCAHTOA. Which one is this? Here's the angle. Here's opposite. Here's hypotenuse. OH, this is sine. Sine of 41 is equal to h over 18. And that's the work that should be shown. And then on your calculator, you type in 18 sine 41. If you type in 18 sine 41, it does say round to the nearest tenth. The height would be 11.8 meters. And one more quick application problem. A wheelchair ramp near the door of a building has an incline of 3.5 degrees. The door is 6 feet off the ground. Calculate the length of the ramp to the nearest tenth of a foot. You got to read carefully. What do they want? The length of the ramp. Okay. So this is 3.5. Now it would be hard to draw an actual picture that the angle is 3.5 degrees. So that's obviously bigger. And even then I had to kind of squeeze it in and my handwriting doesn't look very good. But the drawing doesn't need to be to scale. And the height to the door here is 6 feet. And they want to find the length of the ramp. This would be the hypotenuse of the triangle. I'll call it x. Okay? So from this angle, 3.5, opposite is 6, hypotenuse is x, opposite, hypotenuse, again, that's sine. Now that's a coincidence that both of these problems happen to be sine. They could be anything. But this one is sine, and it's sine of 3.5 is equal to 6 over x. Remember that on this one, all you need to do is type in 6 divided by sine 3.5. Again, it's like you're interchanging the x and the sine of 3.5. You can just interchange them, get x by itself, 6 divided by sine of 3.5. That is 98.3 feet. Okay. That concludes the lesson. Good luck on your homework. Bye-bye.